Hello guys, welcome to my video. In this video, I'll be talking about the boosting technique and Adaboost in particular. So in my last video about random forest, I talked about the bagging technique. So unlike bagging, where a random sample of the training run of the unlike bagging, where a random sample of the training set is given to a base classifier, in boosting we create base learners sequentially, and each base learner learns from the mistakes made by the other base learner. So let's say, for example, we have a data set with 5 records. So let's say, for example, we have a data set with 5 examples. So, and let's say we feed these examples into a classifier. And then let's say this classifier misclassifies 2 records. So let's say it misclassified these 2 records. So these misclassified 2 records are then fed into another classifier, which then makes predictions. Let's say this classifier again misclassified these 2 records. So we then take these 2 records and then feed them into the other classifier. So that's basically how bagging works. So each classifier learns from the mistakes. Each weak classifier learns from the mistakes made by the other classifier. So now let's move on to Adaboost. So what Adaboost does is that it combines a set of weak classifiers. So what do I say when I say a set of weak classifiers? So in Adaboost we use what we call stumps. So a stump is just a decision tree with 2 leaf nodes. A decision with just 2 leaf nodes. So this is what we call a stump. So we use a collection of stumps to we use a collection of stumps to make decisions. So let's take a look at this data set and let me try to explain Adaboost. So let's say we have 3 features. We have x1, we have x2, and then we have x3. And then we have, let's say, the output, which is going to be a, a binary output. And then let's say here we have the sample weight. So let's say we have the sample weight. Let's just draw the border lines. So what Adaboost does is that at the first iteration, each record in our features, they have they have the same weight. So let's say we have 5 records. We have 5 records. Let's say here it will be yes, no, yes, no, and then yes. So here the weight will be 1 over 5, 1 over 5, 1 over 5, 1 over 5, 1 over 5. So all the total number of the sample weight should add up to 1. So if we add up this sample weight, they should always add up to 1. So what we do is, let's say we have a collection of stamps. Let's say this is the first stamp, and then this is the second stamp, and this is the third stamp, which we are going to call x3. So how do we determine which of these following stamps is going to be our base learner? So what we do is we use what we call the entropy. So the entropy is the amount of impurity in a data sample. So let's say here the entropy for the first stamp is going to be 0.24. This one is going to be 0.30. This one is going to be 0.40. So we choose the stamp, we use the stamp with the lowest entropy to be the first base learner for our sequential for all the sequential stamps that we create in Adaboost. So we say that we create these stamps sequentially so that the mistakes made by the first stamp are going to be fed into the second stamp, and then the second stamp is going to learn from the mistakes made by the first stamp. So that's how Adaboost works. So in this case, we are going to choose the first stamp, which is based on the feature X1, which is based on the feature X1. So let's say this stamp, let's say this stamp on the first iteration, these stamps made four correct classifications, but one incorrect classification, one incorrect classification. So what we do before we feed the mistake made by the first stamp into the second stamp, the first thing we need to do is to update these sample weights. So how do we update the sample weights? So the first thing we need to do is we need to calculate the total area. So the total error is the total number of weights, is the total number of sample weight for the incorrectly classified samples. So in this case, our incorrect classified sample was 1. So the total error is 1/5. So keep that in mind. The total error is 1/5. The next thing we need to do is to calculate the performance of this stamp, of this first stamp. So we use a certain formula, which I'm going to say, which I'm going to call the performance, which I'm going to call the performance of stamp is equal to half ln 1 minus the total error divided by the total error. So in this case, it's going to be half ln 1 minus that was 1/5 divided by 1/5, which is going to be, so let me calculate the value. So this value is going to be, 0.9. Ah, sorry, sorry. This value is going to be 0.693. 0.693. So this is the value for the for the performance of our stamp. So you guys might be wondering, why do we need to calculate the performance of this stamp? So this value is important when we want to update the weights. So so to update the weights for the incorrectly classified points, we use another formula, which I'm going to write down. So this formula is the new sample weight. The new sample weight is equal to the previous weight times e to the power of the performance of stamp that we calculated in the previous stage. So this is the formula. This is the formula. So let me just get rid of this decision tree. So here we just create another column. We call it new sample weight. new sample weight. So for incorrectly classified sample, the sample weight for incorrectly classified sample is going to be, remember that we had one incorrectly classified sample. It's going to be 1 over 5 e to the power of 0.693. So, so let's say, so let's just assume that this was the incorrectly classified point. Yeah. So, so now what we can do is just calculate the new sample weight. So it's going to be 0.693 times 1.5. So our new sample weight here is going to be 0.399. So that's our new sample weight. But I said that we had 4 correctly classified points and 1 incorrectly classified point. So what we do to what we do what we do to calculate the weights for the correctly classified points is just we just modify our formula. Instead of e to the power of perform e to the power of the performance of the stamp, we just introduce a negative value. So here the new weight for our correctly classified points is going to be 1 over 5 times e to the power negative 0.693. So here it's going to be 0.10, 0.10, and then 0.10. And then again here it's going to be 0.10. Sorry here guys, it's supposed to be 1 over 5. But the problem is that if we add, the problem is that so the problem is that remember that I said that these sample weights should always add up to 1. But if you add up our sample weights, you will see that they do not add up to 1. So the total is going to be, so the total here is going to be 0.799. So this should be add up to 1. So what we need to do is we need to normalize the sample weights. So we just create another column and then just say normalized sample weight. So normalized sample weight. So what we do here, we divide each of each of these numbers by 0.799. So if we divide 0.399 by 0.799, we get 0.499, which is approximately 0.5. And then if we divide 0.10 by 0.799, we get 0.1125, which is approximately 0.13, 0.13, 0.13, then 0.13. So if you add up these weights, approximately they'll add up to 1, or it will be maybe 0.9, but now they add up to 1. So I want you to take notice of one thing. So remember that I said this is the incorrectly classified points. And if you check out here, when we updated our sample weights, the weight for the incorrectly classified points has increased, as you can see, from 1.5 to 0.5. So this means, so when this weight is increased, this means that the next the next the next classifier is going to put more emphasis on this incorrectly classified point. So it's going to put more emphasis. So that's how Adaboost works. So when we first start, we start with equal weights. But when the classifier makes a mistake, we update the weights so that we increase the weights for the incorrectly classified points. So that the next classifier will put more emphasis on the incorrectly classified points so that it learns from the mistake made by the other classifier. So that's how Adaboost works. So thank you guys for watching this video. I hope this video is useful and you find the video useful. Please subscribe to my channel and also share so that you can help me to reach more people. Thanks for watching, guys. Cheers.